Hello everyone, welcome to RAO'S Academy for Competitive Examination. I'm Rajvardhan Bordekar and today we are going to start another technology, and that is Information and Communication Technology, abbreviated as ICT. ICT is an important technology from UPSC's Prelims as well as Mains examination perspective. In 2022, UPSC has asked 4 questions from ICT technology. From one single technology, 4 questions were asked by UPSC in 2022. In 2024's mains examination, there was one question asked by UPSC from ICT chapter, and that was related to the technology behind electronic toll collection system, and that technology is RFID technology, radio frequency identification technology, that we are going to discuss under ICT chapter, right? So ICT is an important chapter. So what we are going to discuss under ICT, let us firstly understand. We are going to discuss under ICT, firstly we will be discussing about computing, and under computing we will discuss about different types of computers. For example, we will talk about supercomputers, then we will discuss about quantum computers, supercomputers, then quantum computers, and then we'll also talk about cloud computing, edge computing, etc. These are the topics that we are going to discuss under ICT. Firstly, under computing. Secondly, we will be discussing about networking. And under networking we will discuss we'll be discussing about optic fiber cables, then we'll also talk about Bluetooth, Wi-Fi, then RFID, radio frequency identification. This is the technology behind the electronic toll collection system. Then near field communication, NFC, we will be discussing. We'll also discuss about Li-Fi technology, right? That would be under networking. And then after networking, we'll discuss some important technologies. We will be discussing. Which are those important technologies that we are going to discuss? We are going to discuss technologies like, firstly we will discuss about Internet of Things, that is IoT. Then we will discuss about VR, virtual reality, augmented reality, mixed reality, extended reality, VR, AR, MR, XR, all those topics we are going to discuss. And also we will discuss about metaverse, right? Followed by that, we'll talk about 3D printing and 4D printing. 3D printing and 4D printing. Then we'll discuss about blockchain technology, right? And finally we will discuss about cybersecurity. So these are the topics that we are going to discuss under ICT chapter. So let us start with supercomputers. So before we start supercomputers, you can download RAO'S Academy for Competitive Examinations app from Play Store, right? From Play Store you can download this app, and also you can check these two test series. Test series for MPPSC Prelims Examination 2025 and test series for APPSC Group 2 Mains. So these are the two test series that also you can check on the app. So let us move towards our discussion of supercomputers. You can see how exactly supercomputers look. Right, supercomputers does not look like our normal, let's say, PCs. They are in the form of these huge rooms. Right, there would be a huge hall, huge room, and in those rooms we'll be having racks, and each section of the rack would be having a processor of supercomputer. So that way these supercomputers look like. Right, they are not like our normal computers. Fine, so that is the picture of supercomputer. Next now let us try to understand how exactly supercomputers work, or what exactly are supercomputers. Supercomputers are extremely powerful computers. Extremely powerful computers. They are extremely powerful computers, and they can carry out complex computational problems. They can solve complex computational problems. Right? They are extremely powerful computers which can solve complex computational problems, and that is possible because they work on very important principle, and that principle is the principle on which supercomputers work is called as parallel computing. They work on parallel computing. They work on parallel computing. So this is the principle behind the working of supercomputers, called as parallel computing. You should remember this term, parallel computing. What exactly do we mean by parallel computing? In parallel computing, what we do, if there is a problem, that problem would be divided into number of subproblems. It would be divided into number of subproblems, and each subproblem would be assigned to a separate processor of supercomputers. Supercomputers will be having thousands of processors. Each processor would be assigned with a particular subproblem, and that processor would solve that subproblem, and towards the end all the subproblems that are being solved by different processors of the supercomputer would be merged, and then the output would be displayed. That is what is parallel computing. Parallel computing means simultaneously subproblems will be solved by different processors to solve a particular complex problem within a short span of time. That's why we can say that supercomputers are able to perform various tasks in a short span of time, and they are able to solve various complex problems. Why? Because they divide a complex problem into different subproblems, and each subproblem would be solved by a processor of supercomputers separately. That principle is called as parallel computing. Right? So what happens in parallel computing? A problem is divided into different subproblems, which is then solved by the processors of supercomputers simultaneously. Processors of supercomputers simultaneously. That is what is parallel computing. Fine, I hope this is clear to you how exactly supercomputers carry out processing. They carry out processing of data based on the principle called as parallel computing. Fine. Now, as supercomputers are able to solve these problems with the help of parallel computing, their processing power is very high. their processing power is very high, and that's why we have to measure processing power of supercomputers with the help of a unit called as the unit of processing power. Right, the unit of processing power of supercomputers is flops. It is flops. What exactly do we mean by flops? Flops is floating point operations per second. Floating point operations per second. Floating point operations per second. That is the unit in which we measure the processing power of supercomputers. What is the unit in which processing power of traditional computers is measured? Traditional computers processing power is measured in which unit? Unit is MIPS. Unit is MIPS. What is MIPS? It is million instructions per second. Million instructions per second. Right, so that is the unit for measuring computational power of traditional computers. That means our PCs and all. But for supercomputers, what we use flops. You should remember this term, flops. Fine, so these are some of the important points that you should be aware of with respect to supercomputers. Now, supercomputers also have some important features. What are those features? Some of the features we have already referred to, especially the feature of parallel computing. They carry out processing of data based on parallel computing. That we have already referred to, right? So that is one. Second, now as they process huge amount of data, they also have huge amount of memory. So they have huge storage capacity. They have huge storage capacity, right? Now as they are carrying out processing of huge volume of data, what happens? They need advanced cooling technology as well. They need advanced cooling systems as well. Why? Because when the processing of data is carried out, of huge volume of data, when it is processed, it leads to generation of heat energy. And that's why in order to cool these supercomputers down, there is a need of advanced cooling systems. They use advanced cooling systems. So that is also one of the important feature of supercomputers. Next feature is that they have high speed and efficiency. They have high speed and efficiency, and that's why they are used to carry out processing of huge volume of data at a very fast speed. And lastly, the operating system on which supercomputers generally work is Linux. Their operating system is Linux. Fine. So these are some of the important features of supercomputers. I hope you are able to understand what exactly are supercomputers. Supercomputers are those computers that carry out processing of huge volume of data in a short span of time, and to do that they use a principle called as parallel computing. Fine. So that is what are supercomputers. Now, in which applications do we use supercomputers? Let us try to understand. Let us try to understand which are the applications in which supercomputers are used. Applications. Which are the applications in which supercomputers are used? First, supercomputers are used in weather forecasting application. In weather forecasting, which can also be considered as, it can also be referred as climate modeling. It is also referred as climate modeling. So that is first application for which supercomputers can be used. Second, it can also be used for cryptography. It can also be used for cryptography. In cryptography, what we do, in cryptography, a plain text is converted into encrypted text, and this encrypted text is again at the receiver's end. At the sender's end, plain text is converted into encrypted text, and at the receiver's end, encrypted text is again converted into plain text. Fine. Now for this kind of conversion, we need key. For this kind of conversion, what we need key. This key is a mathematical number. It is a complex mathematical number. That complex mathematical number is provided by supercomputers. What they do, supercomputers come up with complex mathematical number which would be used for cryptography purposes. And when we use complex mathematical number, it would be difficult for hacker to crack those complex mathematical number, and hence our data would be secured, would be kept secured. So that is one of the important applications for which supercomputers can be used, and that application is called as cryptography. Fine. Then it is also used for applications like simulation. It is also used for running simulation. For running simulation, we use supercomputers. Now, what exactly do we mean by running simulations? Running simulation means, suppose you have developed one nuclear bomb. Now you want to understand what is the intensity of that nuclear bomb. That means in how much area it can lead to damage. Now it's not possible. You don't have an option of dropping that nuclear bomb to test how much area would be damaged, right? You won't be able to drop it on a certain country to test it. So what you can do, you can run simulations in order to understand the capacity of nuclear bomb, and that would be done on the basis of supercomputers, right? Supercomputers help us in running simulations. Next, supercomputers can also help us in the development of artificial intelligence. It also helps us in the development of artificial intelligence, that is AI. That is AI, right? Because for the development of AI, we need to analyze huge volume of data. That huge volume of data can be analyzed with the help of supercomputers in a faster manner, so that we'll be able to develop AI applications in a short span of time. So that is also one of the important applications. And last application that we can highlight is supercomputers can be used for scientific research. They can be used for scientific research. For example, you want to develop a vaccine. Now, whenever vaccine is developed, vaccines go through a stage called as vaccines are tested before they are sold in the market. Vaccines are tested, and this testing of vaccines has one very important stage called as clinical trials. In clinical trials, that vaccine is tried on a certain set of human beings. Now, when we try that vaccine on certain set of human beings, that would lead to generation of huge volume of data. That data can be analyzed by supercomputers, and hence the process of vaccines development can be streamlined, can be carried out in a short span of time by supercomputers. These are some of the applications for which supercomputers can be used. Fine. So that is what are supercomputers. Now there are some important supercomputers that we have which are considered as topmost or which are considered as the fastest supercomputers of the world. You should be aware of their names. So what are the names of those supercomputers? Top 5 supercomputers of the world. Top 5 supercomputers of the world. First is Frontier. It is of USA. Second is Aurora. It is also of USA. Right? So these two are the topmost supercomputers that we have. Frontier, Aurora. Next is Eagle, again of USA. Eagle of USA. Then fourth is Fugaku. Fugaku of Japan. And last is fifth fastest supercomputer is Lumi. Lumi, and it is there with Finland. Lumi is there with Finland. So these are the topmost supercomputers that we have. They have very high speed. The speed of Frontier and Aurora is in the range of exaflop. Right? It is in the range of exaflop. And 1 exaflop is equal to 10 to the power 18 flops. So it is that fast. And the range of Eagle, Fugaku and Lumi is in the petaflops. Range of Eagle, Fugaku and Lumi is petaflops. Petaflops is 1 petaflop is equal to 10 to the power 15 flops. Right? So speed is not very important. Just you should be aware of these names. Fine. Now, which are the topmost supercomputers that we have in India? So topmost supercomputers in India are fastest supercomputers in India. Fastest supercomputers in India. First is Airavat. Airavat is there at CDAC, Pune. In CDAC Pune, we have this Airavat supercomputer, and it is one of the fastest supercomputers in India. Next, second is Param Siddhi AI. Param Siddhi AI. Param Siddhi AI is also there at CDAC Pune. It is also there at CDAC Pune. Right? Then other two are, next after Param Siddhi AI, next is Mihir, and then we have Pratyush. Right? So these are also some of the fastest supercomputers that we have in India. The fastest right now is Airavat. It is an important name. You should remember this name. Airavat is the fastest supercomputer, and its speed is it is located at CDAC Pune, and its speed is in the range of petaflops. Right? It is around 8 petaflops speed. 8 petaflops is the speed of Airavat. Fine. So that is what are the supercomputers that we have in India. But in India, we are implementing one project, one mission, and that mission is called as National Supercomputing Mission, wherein we are trying to develop a series of supercomputers. So let us discuss about National Supercomputing Mission. National Supercomputing Mission. When it was initiated in 2015 by, it was initiated by Department of Science and Technology, that is DST, and it is also initiated by Ministry of Electronics and IT. Department of Science and Technology and Ministry of Electronics and IT have initiated National Supercomputing Mission. Next, it is implemented by, who is the implementing agency? Implemented by CDAC Pune. CDAC. What is CDAC? CDAC is Center for Development of Advanced Computing. CDAC Pune and IISC Bengaluru. These are the implementing organization for National Supercomputing Mission. What is the aim of National Supercomputing Mission? What is the aim of NSM? Its aim is to establish a series of 70 supercomputers, right? A series of 70 supercomputers across the academic and research institutes of India. Across the academic and research institutes of India, and to form their network. That is what is the aim of National Supercomputing Mission. Its aim is to ensure that there is a series of supercomputers. How many? 70 supercomputers would be established in various research and academic institutes of India, and also they would be networked together. So that the cumulative computational power of these supercomputers would be very high. That is what is National Supercomputing Mission's aim. Now, what are the supercomputers that have been established in various parts of institutes of India? So, first is Param Shivai. And Param Shivai has been established at IIT BHU. IIT BHU has Param Shivai. Second is Param Pravega. Param Pravega. It is established at IISC Bengaluru. IISC Bengaluru. Third is Param Brahma. Param Brahma is established at IIT Kharagpur. IIT Kharagpur. Fine. So that is what is National Supercomputing Mission. I hope this point is clear to you. Under National Supercomputing Mission, we are coming up with a series of supercomputers across various academic and research institutes in India. So that is what is NSM. Next now. So with this, we have completed our discussion of NSM and supercomputers as well. Now we'll be moving towards our next part, and that is quantum computers. You can see how quantum computers look like, right? They do not look like our normal computers, nor they look like supercomputers. It is the shape of, it is how these quantum computers look like. Okay? So let us discuss what exactly are quantum computers. Now this topic is relatively difficult to understand, so please be attentive. Let us discuss about quantum computers. Now, first of all, what exactly do we mean by quantum? What do we mean by quantum? Quantum means atomic and subatomic particles. Quantum means atomic and subatomic particles. Fine. Now, the concepts of physics like motion, force, pressure, etc., that we study during, let's say, school days. You must have studied in your school days about motion, force, pressure, etc. All those concepts belong to classical physics. All those concepts belong to a branch of physics called as classical physics, right? For example, under classical physics, you must have studied about motion. So if you throw a ball against a wall, what will happen? That ball you will be able to catch back, right? It will come back to you. Why? Because there would be action on the wall, and the wall will have a reaction on the ball. As a result of that, that ball will come to you, right? So that is what you must have studied under the classical physics, under, let's say, third law of motion. Fine. But if you take an electron is a subatomic particle. And what is quantum? Quantum means atomic and subatomic particles. So when you take an electron and when you throw that electron against this wall, when you throw an electron, it may be the case that electron may cross to that side of the wall. It will not come back to you. It may cross that particular side. That behavior of quantum particles, atomic and subatomic particles, cannot be explained on the basis of a branch of physics called as classical physics. Classical physics do not explain or cannot explain the behavior of atomic and subatomic particles. And that's why a new branch of physics came into being, and that new branch of physics is called as quantum physics. That new branch of physics is called as quantum physics. Fine. So we will be discussing about various properties of quantum particles which are generally studied as a part of quantum physics. So please be attentive, because this is that topic which is very difficult to understand, but I'll try to simplify it for you. So quantum computers. Quantum computers, let us discuss about quantum computers. But before that, traditional computers. Traditional computers carry out the processing of data in the form of bits, right? Traditional computers carry out the processing of data in the form of bits. What are bits? Bits are 0 and 1, right? Bits are in the form of 0 or 1. Okay? Whenever you send any data, whenever you send any message to your friend, let's say you have sent hi message to your friend, that hi message would be converted into the format of bits. It would be converted into 0101 format. That format is called as bits, and that is what is used in traditional computers. The basic unit of computation in traditional computers is bits. Fine. But in quantum computers, the basic unit of computation is not bits. Basic unit of computation is not bits, but it is quantum bits. It is quantum bits, which is also considered as, which is also called as qubits. It is qubits that is the basic unit of computation in quantum computers. And what are the examples of these quantum bits? The most popular examples of these quantum bits or qubits are electrons and photons. Electrons and photons. So generally, for the computational purposes, in quantum computers, we use qubits, and those qubits can be electrons or photons. It can be electrons or photons that are used for the processing of data in quantum computers. Fine. But why do we use them? That is more important question. Why do we use quantum particles like electrons and photons for the processing of data in quantum computers. This is because these quantum particles, these quantum bits, they exhibit certain important properties. Which properties are the properties that are exhibited by quantum bits? Let us try to understand. Quantum particles exhibit different properties, and the first property exhibited by them is called as, so what we are discussing? We are discussing about the properties of quantum particles that are used in quantum computers for computational purposes. First property is called as superposition. First property is called as superposition. Now we have already discussed that in traditional computers bits are used. In traditional computers bits are used. These bits that are used in traditional computers can be 0 or 1. The bits can be 0 or 1. They cannot be 0 and 1 simultaneously. Either it can be 0 or 1. It cannot be both 0 and 1 simultaneously. But qubits can be 0 and 1 simultaneously. They can be 0 and 1 simultaneously, or they can be of any value between 0 and 1 simultaneously. That property is called as superposition. Right? So what is superposition? Superposition means a property of qubits to be in the state of 0 and 1 simultaneously. To be in the state of 0 and 1 simultaneously. That property is called as superposition. I hope this is clear to you. Fine. Suppose, let me give you one, let's say, non-scientific example in order to understand this. It's not scientific example. When you flip a coin, and when that coin falls on ground, it turns out to be heads or tails. It can turns out to be head or tail, right? So that state is bits. That is bits. Now when that coin is flipped, now you have to imagine something. Now when that coin is flipped, when that coin is in air, when it is in air, it is flipping. It is flipping. That state is superposition. When coin is flipping, are you able to imagine this? When that coin is flipping, it can be in the state of 0 and 1 simultaneously. That state is called as superposition. I hope this point is clear to you. What happens because of superposition? With superposition, the computational speed of quantum computers increases exponentially. Computational speed of quantum computers increases exponentially. Speed of quantum computers increases exponentially. So which is the factor that contributes towards the high speed of quantum computers? It is the property of superposition. It is the property of superposition. Fine. So that is what is superposition. First property exhibited by quantum bits or qubits. Next now, second. Second property is called as entanglement. Second property is called as entanglement. Now what exactly is entanglement? Suppose you have taken two quantum particles, quantum particle 1 and quantum particle 2, and what you have done when you took those quantum particles, you coupled them. You coupled them means you brought them very close so that they started sharing each other's state. You coupled them, right? So we have means this is the first stage. Here what we have done, we have brought them very close to each other so that these quantum particles are able to showcase each other's state. Fine. So you have brought them close together. That means you have coupled them, right? Now once you couple them, they start sharing each other's state. Now after coupling, what you have done, you have separated them. What you have done, you have separated them. You have taken this quantum particle 1 to a certain distance from quantum particle 2, right? That distance can be any distance. It can be a short distance of, let's say, 10 kilometers. It can be a very high distance of, let's say, more than 5 lakh, 10 lakh, whatever is the number, kilometers, right? It may be the case that one quantum particle is on Earth and another is on Moon. So that distance can be any, fine. So what you have done, you have coupled them and then you have separated them. Now when you separated them, both were showing this thumbs up state. Both were showing thumbs up state, right? Now let us consider that this first quantum particle is on Earth and the second quantum particle is on Moon. It is on Moon. Now what you have done, you have changed the state of this quantum particle that you have on Earth. You have changed its state to thumbs down. You have changed its state to thumbs down. What will happen? The state of quantum particle 2, which is there on Moon, would also change to thumbs down immediately. Irrespective of the distance, there would be change in the state of quantum particle 2. This kind of property where the quantum particles share each other's state is called as entanglement. This is the property of quantum particles where they share each other's state when they are coupled, and that sharing of state does not depend on distance. This property is called as quantum entanglement. Fine. Now this quantum entanglement property, what is the use of it? This property can be used for quantum teleportation. This property can be used for quantum teleportation. What is quantum teleportation? Quantum teleportation is a futuristic form of communication, and for that futuristic form of communication we can use quantum entanglement. When we use quantum entanglement for the futuristic form of communication, that communication is called as quantum teleportation. I hope this is clear to you. In 2022, Nobel Prize for Physics was given for the establishment of quantum entanglement property and for its use for quantum teleportation. In 2022, Nobel Prize was given for this. Fine. So that is what is the second property called as entanglement. Next now, third. Third property is called as interference. Interference. Now interference can be of two types. As shown in the diagram, it can be of two types. First is constructive interference. and second is destructive interference. Constructive interference and destructive interference are the two properties shown by are the two types of interferences shown by qubits, right? Now when qubits interact with each other, it may be the case that that interaction is constructive interaction, and as a result of constructive interaction, the properties of qubits can enhance, and thus the speed of quantum computers can enhance, right? You can see here, this is quantum particle 1, this is quantum particle 2. When they interact in constructive manner, what has happened? The speed of quantum computation has increased. But when they interact, this is quantum particle 1, this is quantum particle 2. When they interact in a destructive manner, what happens? They cancel out each other. And that's why we can say that this is the property which can work both ways. It can help quantum computers to increase or to ensure that the computation is carried out in a very high speed, or it can even lead to errors. If the interaction is in a destructive manner, it would lead to errors. Fine. So that is what is interference, third property of quantum particles. So quantum particles, why they are used for quantum computing? Because they exhibit three important properties. Which are three properties? First was superposition, second we discussed was entanglement, and third that we discussed is interference. Fine. I hope these three properties are clear to you. Next now. Now let us discuss about the applications of quantum computers. Where exactly quantum computers can be used? First application is drug discovery. In drug discovery, we can use quantum particles. We can use quantum computers. How? Drug molecules are made up of atoms and subatomic particles. Right? Drug molecules are made up of atoms and subatomic particles. Fine. Quantum computers, QC in short. QC is quantum computers. Quantum computers are also work on the basis of quantum particles, and quantum particles are nothing but atomic and subatomic particles. Quantum computers work also on the basis of atomic and subatomic particles. Now, as quantum computers also work on the basis of as they also work on the basis of atomic and subatomic particles, which are also those particles because of which a particular drug molecule has some kind of properties. It would be easier for quantum computers to understand the properties of drug molecules. Why? Because those properties of drugs are the result of atomic and subatomic particles of which that drug molecule is made up of. Those properties of atomic and subatomic particles of drugs can be studied by the quantum computers. Why? Because quantum computers also work on similar properties. They also work on similar properties, and that's why it is easier for them to understand the properties of drug molecules. Fine. So that is one important application in drug discovery. Second, they also can be used for cryptography. they can also be used for cryptography. This use of quantum computers for cryptography is because quantum computers can give complex, extremely complex keys. Those keys would be very difficult to crack, and hence the communication would be more secure, right? In cryptography, we have just now discussed while discussing supercomputers that they work on the basis of key, and those keys are provided based on some mathematical number, complex mathematical number. Complex the mathematical number, difficult would be to crack those keys. Hence, quantum computers give us such complex keys which are very difficult to crack. That is what is the application in cryptography. Second, third application is to solve the problem of optimization. In order to solve the problem of optimization, we can use quantum computers, right? Now, what exactly is problem of optimization? Problem of optimization. Let us consider that this is the office of delivery agent. This is the office of delivery agent, and this delivery agent from his or her office is supposed to deliver various items, various products, and those products are to be delivered at different houses. Those products are to be delivered at different houses. Fine. So these are houses. H stands for houses. So all these are houses. Fine. Now, problem of optimization is that problem which will be solved in order to ensure that the delivery agent is able to deliver all the goods at all the houses in short span of time by traveling minimum distance. Shortest distance to cover all these houses and to return back to office. That kind of problem is called as problem of optimization, right? Now imagine this kind of problem for huge delivery organizations, like let's say delivery and all. You must be aware of there are a number of delivery organizations. They are able to solve their problem of optimization with the help of quantum computers. Quantum computers can help them understand what will be the shortest route that can be taken in order to deliver all the goods that they are supposed to deliver. That is also one of the important applications of quantum computers. Okay? Next. Next is quantum computers can also be used for climate modeling. Given their high processing power, they can also be used for climate modeling. That means in order to understand the climate in next, or let's say to forecast climatic conditions, to forecast weather patterns, we can use quantum computers, because due to their high computational power, they would be able to analyze huge volume of data in a short span of time. And that's why they are very efficient in coming up with climate models. And lastly, to understand the properties of new materials. We can understand the properties of new materials based on quantum computers. And these new materials then can be used for the development of, let's say, more efficient solar panels. They can also be used for the development of such batteries which can be charged in a short span of time. Those materials can be analyzed, their properties can be analyzed by quantum computers. Fine, so that is what is the application of quantum computers. I hope that is what is quantum computers applications. Next now there is one project, or there is one mission that has been launched by India, by the government of India, and that mission is called as National Quantum Mission. Under National Quantum Mission, what we are trying to do? Initially, under National Quantum Mission, our focus is on developing an ecosystem for quantum computing in India. We want to develop an ecosystem. That means there should be institutions that would be offering various courses on quantum computing. Then there has to be a human resource that can be used for the development of let's say newer applications, right? So creation of an ecosystem is the focus. First, once ecosystem is created, the next phase would be dedicated to the development of quantum applications, and those quantum applications can be used in the field of cryptography. It can also be used in the field of communication, right? So that is what is National Quantum Mission launched by Government of India. It focuses firstly on the creation of ecosystem, and based on that ecosystem we will be developing newer quantum applications in India, right? So that is what is National Quantum Mission. Now we will move towards our discussion of cloud computing. Now let us discuss about cloud computing. So what exactly is cloud computing? Cloud computing means delivery of services like storage, softwares, networking, etc. over the internet. Right? When various services like networking, computation, storage, softwares are delivered over the internet, that would be considered as cloud computing. That would be called as cloud computing. Fine. So what is cloud computing? It is delivery of various computational services over the internet. For example, suppose you are watching YouTube. On YouTube, when you click or when you are watching YouTube, those YouTube videos, are they downloaded in your mobile phone? No, they are not downloaded in your mobile phone, right? So when you click on the thumbnail or description of a particular video, what you click actually is the link. You will be clicking the link of that particular video, and once you click that link, what happens? You will be taken to the storage where that particular video is stored, and it may be the case that video is stored thousands of miles away in some other country. For example, from India, you will be able to access video stored in California. That is what is the delivery of services over the internet. This form of service delivery is called as cloud computing. And where all that data is stored, where all those videos are stored, that form of storage is called as cloud. Fine. So what is cloud computing? It is delivery of various computational services over the internet. Fine. Now, there are some important features of cloud computing. What are those features? First is on-demand availability. Suppose you are a startup and you want storage for your data. In your startup, you are generating lots of data and you want to store that data. Now there are two options with you. First, to have your own data center. In your organization, you'll have to develop a data center, and that data center would need lots of hardware. It would need personnel, that means human beings who will handle that data center. You will need cooling systems as well, and also you will need applications or softwares which would be protecting your data, right? Your data should also be protected, and for that you will need various kinds of software. So those four things you need in order to establish a data center in your own organization. But there is second option available with you, and that option is to write an email to the cloud service provider so that you will be able to get access to the storage from that cloud service provider. Which one is more better? Second option is better. Why? Because all the headache with respect to handling of data would be transferred to the cloud service provider. And that's why we can say that the availability of cloud services are on demand. Whenever you demand, you will be able to get the access of those services. First. Second, scalability. Scalability is the second advantage. Now, what exactly, or second feature, what exactly do we mean by scalability? Suppose you are a startup and you are storing your data on the cloud, right? Now, in the first year of your operations, you had taken storage of 1 TB. You took the storage of 1 TB. In the second year, your operations expanded and the data that you are generating is huge. So what you have to do, you have to increase your storage. Simply what you have to do when you are storing your data on cloud, you just have to demand another storage from the cloud service provider. Another extra storage you will be demanding. And that's why we can say that cloud services are scalable in nature. You can increase the storage that you want whenever you want, and you can even decrease it. That is what is the feature of cloud computing. Next feature is accessibility, or anywhere, anytime accessibility. Anywhere, anytime, anywhere, anytime accessibility. Anywhere, anytime accessibility. That means you will be able to access data that you have stored on cloud from anywhere at any time. Only need is that you need access of internet. You only need access of internet. So that is also one of the important features of cloud computing. Next feature is pay as you go. That means whatever cloud you are using, whatever part of cloud that you are using, you only have to pay for that much part. You don't have to pay anything extra. So whatever you are using, for that you will have to pay the price. You will have to pay the money for that only, not for other part of cloud. Fine. So that is also one of the important advantage or feature of the cloud computing. And that's why we can say that cloud computing is one of the cost-effective measures to store your data, to get access of softwares, etc. Right? So that's what are the features. But there are some disadvantages as well. These features can also be considered as advantages. There are some disadvantages. There are some disadvantages of cloud computing. What are the disadvantages? First is lack of offline access. Lack of offline access. That means you need access of internet when you want to use cloud computing. Suppose you have stored data on cloud, then in order to access that data, you will need data. You will need internet service. Without internet service, if you are offline, you won't be able to access cloud services. That is one of the problems with respect to cloud. Also, it has problems, for example, centralization of data. In cloud, it is the case that data of various organizations would be stored. As data of various organizations is stored, it leads to centralization of data. And when centralization of data is there, there are threats with respect to cybersecurity. Cybersecurity threats would be there for the cloud, right? That is also one of the important disadvantage. Next, high data travel. High data travel is there. That means, what do we mean by data travel? When you use cloud, firstly, data that is generated in your organization will flow from your organization to cloud, and then it will be stored on cloud, right? Now, when you want to use that data, again, that data would flow from cloud to your organization. This kind of flow of data from your organization to cloud and back is called as data travel, right? It is called as data travel. And this data travel is over the internet. Internet being the public network, it is vulnerable. And that's why if high data travel is there, that makes your data vulnerable to cyber attacks. That also makes your data vulnerable to cyber attacks. Fine. Next is high latency. High latency. That means there is lag in the cloud services. Suppose you clicked a YouTube video. YouTube video, when you click, it takes certain amount of time to play. That is what is latency or lag or delay. High latency means high lag. Fine. And as a result of high latency, what happens? As a result of high latency, what happens? As a result of high latency, there would be or cloud would not be very helpful for time sensitive applications. Hence, next disadvantage is not effective for time sensitive applications. Cloud computing is not effective for time sensitive applications. For example, what do we mean by this? For example, suppose you want to use your mobile phone for facial unlock. You want to use your mobile phone for facial unlock. So when you start using this feature of your mobile phone, firstly, your mobile phone collects data. Your mobile phone collects data of your face. Right? It will ask you to turn up, right, left, right, all those things will be done, so that all facial features would be captured. Right? Now that captured data, imagine that it is stored on cloud. Imagine that the captured facial data is stored on cloud. Fine. Now, when you want to, next time, when you want to, let's say, unlock your phone with the help of facial unlock feature, and you took your mobile phone in front of your face, your mobile phone captured data of your face. That captured data would be compared with the stored data which is there on cloud, right? Your captured data, captured facial data would be compared with the stored facial data, and where it is stored on cloud. Now this comparison may take time, and that's why may be the case that your mobile phone would be unlocked after 5 to 7 seconds. If it takes 5 to 7 seconds for a mobile phone to get unlocked, it cannot be considered as a good application. It cannot be considered as one of the advantages. It is a disadvantage. Fine. So for time sensitive applications, cloud computing is not very effective. Fine. So these are some of the disadvantages with respect to cloud computing. Now cloud computing also provides certain important services. If you want to take screenshot, you can take. Now cloud computing provides three types of services. Let us discuss those services. Services provided by cloud computing. First is infrastructure as a service, abbreviated as IaaS, infrastructure as a service. Second service is platform as a service, that is PaaS. And third service is software as a service, that is SaaS. So IaaS, PaaS and SaaS are the services that we get from cloud computing. So what is IaaS? IaaS is that service where individual or organization can rent infrastructure. Infrastructure can be rented. Infrastructure can be rented. And what kind of infrastructure? It can be storage, it can be a network, or it can even be virtual machines. Those can be rented on IaaS, service provided by cloud computing. Fine. What is the example of it? Example is Amazon Web Services. Amazon Web Services. That is what is IaaS. Fine. Next, platform as a service. What is platform as a service? Platform as a service is that cloud service where software development platforms, software development tools would be given on rent. Right. So what is PaaS? It provides development environment for the software development. What it provides? It provides development environment. Development environment or development tools. It provides development, software development tools is better. It provides software development tools. Software development tools. Software development tools are provided from cloud, and that kind of service is called as platform as a service. What are the examples? Example is Google App Service. Google App Service is the example of PaaS. Google App Service is an example of PaaS. Fine. Now last is software as a service. Software as a service means what we get in software as a service. In software as a service we get access to final, or instead of saying final, access to usable softwares, access to fully functional softwares will be given. Access to fully functional softwares. Would be provided. Access to fully functional softwares would be provided, and this is based on subscription. This kind of access to softwares would be based on subscription. You have to subscribe to those softwares and you will be able to use those softwares. What is the example of software as a service? It is Google Workspace or Microsoft 365. Google Workspace or Microsoft 365. Fine, so that is what is cloud computing. I hope this is clear to you. Fine, so cloud computing is a delivery of various computational services like infrastructure, like platform, like software over the internet. Fine, I hope this is clear to you. If you want, you can take a screenshot. Next now. Now we discussed that there is one problem with respect to cloud. There is one problem with respect to cloud, and that problem is that cloud services are not very effective when it comes to time sensitive applications. For time sensitive applications, cloud computing cannot be used. Why? Because it takes certain amount of time for cloud to deliver services, and hence what we use edge computing. We use edge computing. Now what exactly do we mean by edge computing? Let us try to understand. In edge computing, data is stored. In edge computing, data is stored and processed on the devices. Data is stored and processed on the devices that have generated that data. The devices that have generated that data would be stored as well as processed on that device itself. For example, we took example of facial recognition, facial unlock feature. Now, in case of facial unlock feature, when initially you start using facial unlock feature, that device will ask for your facial data. You have to turn up, right, left, right? So that data of your face would be captured. That captured data would be stored in your device itself. On the mobile phone itself, that data would be stored. It will not be stored on cloud. Fine. And when you use facial unlock feature next time for unlocking your phone, what happens? Your face data would be captured. When you take your mobile phone, your face data would be captured, and that captured facial data would be compared with the stored facial data. And that storage, that comparison of captured data and stored data is a kind of processing of data, and that processing of data would also occur on your device itself. And that's why the processing of data in edge computing would be faster. Processing of data in edge computing would be faster. Fine. So what is edge computing? Edge computing is that technology where data is stored as well as processed on the devices that have led to generation of that data. Fine. And as a result of that, what happens? We will be able to access that data in a short span of time. Right? For example, these days, the facial unlock feature, if you use, it gets unlocked. Your phone gets unlocked with your facial feature within short span of time. Within blink of eyes, it gets unlocked. That is because data is stored and processed on your mobile phones. Fine. Now, what are the advantages? What are the advantages of edge computing? First advantage of edge computing is that the proximity is there with the data source. Right? Data would be proximate, would be near to the data source itself. That means your device. Second, low latency. Low latency, the lag or the delay that was seen during cloud computing is not there in case of edge computing. Next, also it leads to bandwidth optimization. It leads to bandwidth optimization. What do we mean by bandwidth optimization? When you access your data stored on cloud, you have to spend some data, right? You have to spend some data in order to access that data that is stored on cloud, right? Internet, you have to spend some internet data in order to access data stored on cloud, right? So that is a kind of wastage of the resource. That kind of wastage is not involved in edge computing. Why? Because your data is stored on your device itself, and even if you're offline, you will be able to access your data. So that is what is bandwidth optimization. And next advantage is also an extension of it only, and that is offline access is available. Offline access is possible. Okay, so these are some of the advantages of cloud computing. One more advantage before we move to further next point: data security. Data security is ensured due to decentralization of data. Due to decentralization of data, right? So here data is stored on many devices, and as a result of data storage on many devices, hacker will avoid attacking those many devices. Why? Because hackers would be looking for centralized database where by one attack they'll be able to access multiple data. That is not possible in case of edge, and hence data would remain more secure in case of edge computing. Fine. Last, disadvantages. Despite these advantages, there are some disadvantages as well. First disadvantage is that lacks scalability. It lacks scalability, right? We discussed that for cloud computing, scalability is very easy. How you can scale up and scale down, but by just writing an email. You just have to write an email to scale, to increase your storage or decrease your state. But in case of edge computing, scalability is not possible. If you want to increase storage, what you have to do? You have to change your device itself. You'll have to change your device itself. And that's why that is one of the problems with respect to edge computing, that it lacks scalability. Fine. Next, high cost of processing. High cost of processing data. Fine. The data that you are storing, in order to process that data, there is high cost involved. Why? Because the data processing would need some resources, and you will have to ensure that your device has those resources. For example, it should have very high RAM. That RAM would make sure that you are able to process huge amount of data in a short span of time. So processing power is required, and that's why the cost of processing increases. Next is due to decentralized storage. Data may become vulnerable. data may become vulnerable, right? So if storage is decentralized, we discussed that it is a kind of advantage. If storage is decentralized, it is a kind of advantage. But now we are discussing that it is a disadvantage as well. How? Because generally, as data is stored in the user's device, user might not take enough care to protect that data, right? For example, when we install some app, we give all the permissions. That means we are not aware exactly about the cyber security, and that advantage can be taken by the hackers. And hence, data, even if decentralized, may be accessed by, may be breached by the hackers. And that is also one of the disadvantage with respect to edge computing. Fine, I hope this is clear to you. But the application of edge computing is there for time sensitive applications. For example, in the facial unlock, even in autonomous vehicles, we can use edge computing, because autonomous vehicles will also be categorized as time sensitive application, because they have to take decisions in a quick manner, and hence the data generated by those vehicles should be stored in their in the vehicles itself. And that's why in autonomous vehicles also we can use edge computing. So that is what is edge computing. I hope this is clear to you. Now with this we have completed 4 types of computers or computing. First, supercomputers, quantum computers, cloud computing, and edge computing. Now we will be moving towards our discussion of networking. Before moving towards the networking, again you can download this particular app of RAO'S Academy for competitive examination. Also you can check the test series on MPPSC Prelims examination 2025 and APPSC Group 2 mains examination for 2024. Now networking. Let us discuss about networking. What exactly do we mean by networking? Networking means to connect various computers, various computer systems with each other, to optimize their usage. Right? When we connect different computers with each other, we will be able to optimize their usage, and that form of connection of computers is called as networking. Networking is of 2 types. First, networking is of 2 types. First is wired networking. And second is wireless networking. Wired networking and wireless networking. As name suggests, wired networking would be using some kind of wires or cables. What they use? They use some wires or cables in order to connect various computers. Fine. The most common wires that are used these days are optic fiber cables. Example, optic fiber cables. These are the most important wires that are used for connecting various computers today. Next, now under wireless networking, we use, more often than not, we use radio waves. Radio waves are used for connecting different computers with each other, right? For example, in Wi-Fi also we use radio waves, right? But sometimes we can also use optical radiations. optical radiations, which are also called as visible radiations, are used for wireless networking. Fine, for wireless networking, more often than not, radio waves are used, but sometimes optical radiations, that means optical radiations are nothing but visible radiations, they can also be used. What are the examples? Bluetooth, Wi-Fi, RFID, NFC, and Li-Fi. These are different technologies that we are going to discuss now. Let us start with fiber optic cables. Fiber optic cables. Right, so fiber optic cables, as we have already pointed out, are the most popular cables that are used for wired networking. What kind of structure do they have? So optic fiber cables consist of a core that is made up of glass. Right, they consist of core. Core is surrounded by cladding. Core is surrounded by cladding. Cladding is also of glass. Cladding is also made up of glass, and cladding is surrounded by insulation. Cladding is surrounded by insulation, and this insulation can be of rubber, it can be of plastic as well, right? And from outside it is the insulation that we can see, but inside the cable there would be glass core and glass cladding. Fine. Now in this glass core, what we are using in optic fiber cables, we use light radiations are used to transfer data. Light radiations are used to transfer data from one place to another. Fine. So how data transmission is carried out? Data transmission is carried out with the help of light radiations. So when light radiations move from this core, and as this core is made up of glass, we may think that this light may escape out of the core. We may think that this light radiation that is being used for the data transmission may escape from core, but that does not happen. Light radiation does not escape from core. Why? Because the angle of incidence, because when light falls on the edges of core, the light is reflected inward. Light is reflected inward. Why it is reflected inward? Because the angle of reflection of this light radiation is less than the critical angle of 42 degree. Right? The angle of reflection of the light radiation that is falling on the edges of glass core is less than 42 degree. This angle is critical angle. 42 degree is critical angle, and the angle of reflection is less than 42 degree, and as a result of angle of reflection less than 42 degree, the radiations would be reflected inward, not outward. That is why we can say that data in the form of light radiations do not leak out of the core of optic fiber cables. This principle is called as total internal reflection. Next point. optic fiber cables do not leak out data as the angle of reflection of the light radiation from the edges of core is less than 42 degree, right? The angle of reflection is less than 42 degree, and hence the reflection is not, or the radiations do not go outside, they are reflected inward. This is called as, this phenomenon is called total internal reflection. TIR, right? So very important point. Optic fiber cables work on which principle? They work on total internal reflection principle. Fine. So that is what is optic fiber cables. So this is the most important cables that we have today, and these cables are used in one of the important projects that is being carried out by Government of India, and that project is called as BharatNet. Under BharatNet project, we are connecting various gram panchayats in India with internet, and in order to connect those gram panchayats with internet, we are using fiber optic cables. That is what is fiber optic cables. Now let us move towards our discussion of next topic, and that is Bluetooth, Wi-Fi. Bluetooth and Wi-Fi. Now when we discuss about Bluetooth and Wi-Fi, these are wireless technologies. These are wireless communication technologies. So, not optic fiber, it's Bluetooth. It is so Bluetooth and Wi-Fi, they both are wireless communication technologies, right? So in wireless communication technology, what do we use? More often than not, we use radio waves. Radio waves are used for wireless communication. So firstly, let us discuss about Bluetooth. So Bluetooth is short range communication technology. It is short range communication technology. And what is the range? Range is 10 meters. Range of Bluetooth is 10 meters, right? And it leads to formation of personal area network. Within a particular range, it would be forming personal area network. Personal area network, right? And it uses radio frequency of 2.4 gigahertz. It uses radio waves of 2.4 gigahertz. 2.4 gigahertz, right? It establishes personal area network, which is also called as PAN, and this technology is highly secure. It has more security. Why it has more security? Because if the hacker want to intrude into the Bluetooth network, then hacker will have to be within that particular range of 10 meters, right? So suppose you are using a mobile phone and you have connected your mobile phone and let's say AirPods, then those AirPods and Bluetooth AirPods and your handset are very close, and if hacker want to intrude in this, hacker will have to sit beside you, and that's why it is considered as very safe.
Fine. So that is what is Bluetooth. Next, but the range is very limited, and also the data that is shared through Bluetooth network is also limited. So that is what is Bluetooth. Next we have Wi-Fi. Wi-Fi, its full form is wireless fidelity. Wireless fidelity. Fine. In Wi-Fi, we use radio waves of two different frequencies. It may be 2.4 gigahertz or 5 gigahertz. 2.4 gigahertz and 5 gigahertz. Right. As in 5 gigahertz we are using more frequency, we will be getting more bandwidth, and that is why large volume of data can be shared, and hence speed of Wi-Fi is more, right. And in the modern or in the latest versions of Wi-Fi, 6 gigahertz frequency is also being used. So what is the range? Its range is 60 meters to 100 meters. Right, its range is 60 meters to 100 meters. So that is the range, and what it establishes? It establishes local area network. Local area network, that is LAN. It establishes LAN. Fine. So that is what is Wi-Fi and Bluetooth. Next now, both these are wireless communication technologies. Next we will discuss about radio frequency identification. Radio frequency identification, again it is a short range communication technology. It is a short range communication technology. What is the range? Range is 10 to 15 kilometers. No, sorry, 10 to 15 meters. 10 meters to 15 meters is the range of radio frequency identification, and we will discuss about radio frequency identification based on its application, and that application is fast tag. RFID is used in fast tags. It is used in fast tags, right? And these fast tags are used for automatic toll collection. You must have seen on your vehicle, you have a fast tag, and that fast tag would help you deduct toll at the toll booths, so that you will be able to move from toll booths very fast, right? So for automatic toll collection, we are using radio frequency identification based fast tags. So these fast tags, they consist of two parts. One is tag, and second is reader. Tag and reader. This reader is at toll booth. It is at toll booth, and this tag is on your vehicle. This tag consists of two parts. It consists of a chip and antenna. It consists of a chip and antenna. Now, reader is there on toll booth. This reader continuously emits. Radio waves. So it emits continuously radio waves. Those radio waves are captured by antenna of your tag. Your antenna of tag will capture radio waves emitted by reader, and these radio waves coming from reader consist of a request of information stored on your chip. Your chip consists of information like vehicle number. It consists of information like vehicle number and bank details. Right? So that information would be requested by reader. So what your antenna does, antenna sends this information. This information would be sent towards reader by antenna. This reader is connected to a It is connected to a computer. It is connected to a computer. The information that is provided to reader by this antenna, that information is vehicle number and bank details. That information would be sent by this reader towards this computer. This computer uses your information, uses that information in order to collect toll, and then you will be able to move from that toll. So that is how RFID works. RFID consists of two parts. First is the tag, second is reader. Tag consists of a chip which consists of information about the let's say if it is used for toll collection, the information would be about vehicle number and bank details. That information would be sent towards the reader by antenna of the tag, and thereby you will be able to let's say deduct toll and you will be able to move, right. So that is what is radio frequency identification. It is a short range communication technology, and this technology is, it is not a line of sight technology. This technology is not, it is not a line of sight. That means the reader and your tag should not be in line of sight, right. There should not be, let's say this is reader, your tag should not be in front of the reader directly, right, and that's why it is called as it is not a line of sight technology. Even if reader is not directly in the line of sight with tag, then also this technology is going to work. Fine. So that is what is radio frequency identification. Another application of it, one of the application we have discussed is used in FASTag. Another application is in shopping complexes. In shopping complexes, RFID is used. You must have observed that when you go for shopping of clothes, when you want to buy some clothes, those clothes in the store have a red color, have a gray color or black color tag, right. It consists of a tag which is removed at the billing counter. At the billing counter they remove those tags. So those tags are nothing but RFID tags. Those tags are also RFID tags. And if you have noticed this, at the exit of shopping complex, at the gates there are two poles. Those poles continuously emit radio waves, right, and that is what is a reader. Fine. So suppose there is a person who is trying to take clothes out of the shopping complex without billing. That means stealing, right. Suppose there is a person who is stealing those clothes. So as those tags are intact, what will happen? The person would be able to, person if moves out of the exit, the reader would detect the clothes. Reader would be able to detect the clothes, and thus that person would be caught. So that is also one of the use of radio frequency identification. I hope these applications are clear to you, and this is what is RFID technology. If you want to take screenshot now. Next. So that is RFID. Next technology that we are going to discuss is NFC, near field communication. Near field communication. Near field communication is also a short range telecommunication technology. It is also a short range telecommunication technology. What is the range? Range is 4 centimeters or less. Range is 4 centimeters or less. It is very short range, right? Almost you have to touch the devices in order to use near field communication, right? Now, where exactly near field communication is used, and then we will discuss how it works. So it is used in, its applications are in tap to pay, It is used in tap to pay features. Secondly, it is used for contactless ticketing. It is used in contactless ticketing. For example, in metro cards. In metro cards use NFC, right? Also, it is used for access control. You must have seen that in order to enter in some office, those employees of office have to use some card. That card they will have to scan against a scanner, then only they will be able to move. Fine. So, that is what is access control. So, in all these applications, near field communication is used. So, let us try to understand how exactly it works. We will discuss it on the basis of an application called as tap to pay. So, in tap to pay, how it working. So, we will discuss working on the basis of tap to pay feature. Now, in tap to pay feature, there are two parts. First is POS machine. POS machine, point of sale machine, right? Point of sale machine is nothing but the machine on which you swipe your cards, right? In any store, you must have seen that there are machines against which you can swipe your cards. Those machines are called as POS machine, right? And another part of tap to pay is let us say a debit card or credit card. Another part is credit card, which consists of a chip. Its credit card consists of a chip where information would be stored. Now, in tap to pay feature, what happens? This POS machine, you have to bring them close. These two parts, you will have to bring them very close. So, this POS machine emits radio waves. What it does? It emits radio waves, right? As a result of radio waves emitted by POS machine, this POS machine would be able to generate a magnetic field around it. These radio waves generate magnetic field. Radio waves, what they do? They generate magnetic field around the POS machine. For example, the magnetic field looks like this. Suppose this is the magnetic field generated by the POS machine. Now, when you take this credit card close to this POS machine, when you take your credit card close to this POS machine, this magnetic field around POS machine would induce a current in your credit card. A current, small current would be induced, which will power this credit card, right? As you take your credit card in the magnetic field around POS machine, the magnetic field will induce a current in your card. That current would power your credit card, and it would transfer the information stored in its chip to the POS machine, right? This credit card, when you tap it against POS machine, what happens? The information stored in the chip of credit card would be transferred to POS machine, and then POS machine will read that information, will use that information, and will carry out the transaction. You just have to enter your PIN in order to ensure that the transaction has been carried out. That is what is the functioning of tap to pay feature, or that is what is the functioning of near field communication. I hope this is clear to you. Same thing happens in the metro cards as well. Your metro cards consist of information. right? Information about the amount present in that particular metro card, right? So when you take your metro card towards the scanner on metro station, what happens? That scanner on metro station emits radio waves, and that emission of radio waves lead to creation of magnetic field. And when you take your card around that particular scanner, what happens? There would be a connection established between these two, and your card will transfer the information of the amount present in your card. That way NFC works. I hope this is clear to you, right? NFC uses two important things. First, radio waves, and secondly, it uses magnetic field. Why magnetic field is used in NFC? Because the magnetic field used in NFC fades very fast. It fades away very fast, and that's why no one would be able to intrude in your communication. The magnetic field would be present for a very short span of time, and that would make sure that there is no one who is able to intrude into the communication. That is how the near field communication technology works. I hope this is clear to you. Next now, so that is about NFC. Next we will be discussing about Li-Fi. That is light fidelity. What is Li-Fi? It is light fidelity. So as the name suggests, light fidelity, here we do not use radio waves. What we use visible light radiations. Visible or optical radiations are used. Visible or optical radiations are used in Li-Fi technology. Radio waves are not used. Fine. Now, as you can see, there are these LED bulbs. And these LED bulbs will be having micro LED. It will be having micro LED, and that micro LED will be switching off and switching on. As they switch off, they transmit a value of 0, and when they switch on, they transmit the value of 1. So that way data is transmitted from these LED bulbs, and that would ensure connection between the router of the router of Li-Fi and the devices. How data is transmitted from the Li-Fi router and devices? It is transmitted by modulating light by LED bulbs, and that modulation of light is not seen, not visible for human eye. When the small LEDs on this particular router, they switch off, that is not visible for us. When they switch on, again there would be no change in the intensity that would be seen by us. And hence, by simply modulating light radiations in Li-Fi, there is data transmission. For data transmission, hence we can say that what is used? Optical radiations or visible light radiations are used. As visible light or optical light radiations are used, we can say that the bandwidth provided by Li-Fi is more. Bandwidth provided by Li-Fi is more, and as a result of more bandwidth, what happens? Speed of Li-Fi is more than Wi-Fi. The speed provided by Li-Fi would be more than Wi-Fi. And how many times it is more? Many different numbers are there, but it is said that it is more than 100 times. 100 times speed of Wi-Fi is provided by light fidelity or Li-Fi. But problem is that it is a short range technology. It is a short range technology. You can see in this particular picture where that light is falling. Where that light is falling, only in that place there would be availability of data transmission. If someone goes outside of that light, there would be no data access that person will be able to have, and that's why it is short range, and that is a disadvantage, because in Wi-Fi we know that range is 60 meters. Range of Wi-Fi is more than Li-Fi. Similarly, one more disadvantage is there. It is wastage of energy. There is wastage of energy as well. Why? Because even during daytime, just to carry out a data transmission, you have to switch on lights, and that is a wastage of energy, right? So these are some of the points with respect to Li-Fi. Now, one more important point with respect to Li-Fi is its application. So let us discuss about the applications of Li-Fi. So Li-Fi, obviously, as it is a communication technology, it is used for the provision of data transmission, but it is especially important for two sectors. It is especially important for two sectors. First is in-flight data communication. In-flight data communication is one application, because in flights we know that we are supposed to switch off our mobile phones. Why we are supposed to switch off our mobile phones? Because there should not be any disturbance in the communication between the air traffic control on earth, on ground, and the pilot inside the aeroplane. There should not be any disturbance in the communication of these two, and that's why we are supposed to switch off our mobile phones, which are also dependent on the same radio waves that are being used by air traffic control and pilot, right? So what we can do, instead of using radio waves, we can use light radiations, visible light radiations, for provision of in-flight data communication services. That is one. Second, it can also be used in hospitals. It can also be used in hospitals. In hospitals also, there are number of radiations that are being used. For example, we use X-rays. Sometimes there would be other radiations as well present in the hospital, and that's why it is advisable that we should not use our mobile phones inside the hospitals. Why? Because our mobile phones are based on radio waves. So hospitals also, what we can use Li-Fi technology for the data communication, for the communication purposes. So these are the two sectors where Li-Fi can be preferred. Fine. So that is what is Li-Fi. Next now. Next. Now, apart from these important ways of communication, there is another form of telecommunication, and that is based on satellites in Earth's orbit. So space-based internet. Space-based internet services are based on satellites launched in LEO. It is based on satellites launched in LEO. From satellites in LEO, we will be able to provide data communication services. What they provide? They provide broadband services, broadband internet services are provided by these satellites. To which areas? To remote areas. To remote areas, right? From the satellites placed in low Earth orbit, we will be able to provide broadband internet services to remote areas, and that is why the space-based internet services would be a kind of revolution in future, because it would be bridging, it would help us bridge the digital divide that is present between rural and urban areas. In rural and urban areas, there is digital divide that we will be able to bridge with the help of space-based internet, right? And it is being provided by various kind of organizations. For example, what are the examples? First is Starlink by SpaceX. Starlink by SpaceX. OneWeb by London-based organization. OneWeb by London-based organization, and that organization, there is one more partner, and that partner is Bharti Airtel. Bharti Airtel is a partner in OneWeb, and one more is Project Kuiper. Project Kuiper, and this is by Amazon. By Amazon, right? So that is what is space-based internet. It is the internet service that is provided based on satellites in low Earth orbit, and that's why as satellites are providing telecommunication services from low Earth orbit, more than 1,000 satellites are needed for these kind of services. It is said that Starlink is based on 2,000 to 3,000 satellites in low Earth orbit. For Starlink project, 2,000 to 3,000 satellites have been launched by SpaceX in low Earth orbit. Okay? So that is what is space-based internet. Next now. Now we will be, so you can check this app, you can check RAO'S Academy for Competitive Examinations app, and it is available on Play Store, Google Play Store. Also, you can go through the test series for MPPSC Prelims Examination 2025 and APPSC Group 2 Mains Examination 2024, right? So both these test series you can check on the app. Next. Now we will be discussing about some important technologies. We are done with computing, we are done with networking as well. Now some important technologies we are going to discuss. So let us start with those technologies. First is Internet of Things, which is also considered as, also called as IoT, right? As you can see in this particular picture, there are a number of physical world devices. For example, cars are there are cameras, mobile phones, routers, laptops, even houses, right? So all these objects, even you can see the refrigerator here. When all these physical world devices we connect with the internet, we will be able to regulate these devices in a better way. And that technology is called as Internet of Things. So let us try to understand in a better way what exactly is IoT. What is IoT? So IoT, as name suggests, IoT is Internet of Things. It is Internet of Things, where these things are physical world devices. These things are physical world devices, right? And when we connect on, what can be the examples of physical world devices? Any physical world device, be it a car, refrigerator, AC, washing machines, coffee machines, whatever, right? All those physical world devices, when are connected with the internet, when we connect these physical world devices with the internet, we will be able to, we can control them, control or regulate them for their efficient utilization. For their efficient utilization, right? You can make sure that the AC machines, ACs are operated from any part of the world, right? Using your mobile phone, you can operate AC from any part of the world, right? When cars are connected with the internet, those cars would be sharing their coordinates, will be sharing their location every second. And if all, imagine the scenario where all cars on the road are connected to the internet, and as they share their location information every second, no one would come close to each other, and that's why road accidents would be a thing of past. That is what is Internet of Things, right? There was one passage which was asked by UPSC in 2018's prelims examination, and in that passage they referred to Internet of Things only, right? I'll tell you what was the passage that UPSC asked. So the passage is like, suppose you wake up in the morning, your alarm rings in the morning and you wake up. As soon as you dismiss your alarm, automatically geyser in your bathroom gets switched on. Automatically geyser gets switched on. So geyser is first product. When you go in your bathroom, there is a smart mirror. That smart mirror tells you about the water level in the overhead tank. How much water is in the overhead tank, that would be told to you by your smart mirror. And also that smart mirror tells you about the weather conditions, right? So your smart mirror is the second object. Now, when you go to prepare your breakfast, your refrigerator understands that your refrigerator gets the information that the grocery items in your refrigerator has fallen, means the the quantity of grocery items has reduced. So what your refrigerator can do, your refrigerator can automatically place order with the grocery shop. That is third, refrigerator. When you are about to move to your office, and when you close the door of your house, automatically all the switches get switched off, all the lights gets turned off. That is 4. And lastly, when you are moving towards your office, your car tells you which is the shortest route that you can take to reach your office. So these 5 things are the physical world devices, but they have been connected to the internet so that you will be able to use these products in a more efficient manner. That is what is Internet of Things, right? Where exactly we can use Internet of Things? There are number of applications where we can use Internet of Things. For example, just now we discussed about smart homes and smart cities, right? They can be used in smart homes, smart cities. Thirdly, they can be used in health sector. In health sector, what you can do, you can attach wearable devices with the patients. Those wearable devices will be monitoring critical data of patients, and that data would be supplied to the central database, and that would be used by the doctors in order to understand the condition of patients. That is what is Internet of Things in healthcare sector. One more, agriculture sector. Agriculture. Now, agriculture application is highly futuristic. So, I'll explain what it is. So, how we can use IoT in agriculture? In agricultural fields, there would be sensors. And those sensors are analyzing level of moisture in the soil. What those sensors do? They analyze the level of moisture in the soil. And if the soil moisture level falls below a particular level, what happens? Automatically the signals would be sent to the motor, and the motor would switch on, will carry out the irrigation of the agricultural field. That is what is Internet of Things. Fine. So I hope this is clear to you. These are the applications in which Internet of Things can be used. Fine. Next now. Next is virtual reality. Virtual reality. or VR, abbreviated as VR. So what exactly is virtual reality? It is use of virtual reality headsets, right? In virtual reality, what is used? Virtual reality headsets. You must have seen those big headsets which are applied over the eyes, right? So they use virtual reality headsets to immerse user into a virtual world, right? User is immersed into a virtual world, and contact with the physical world is broken completely. Contact with the physical world is broken completely, right? So what is done in virtual reality? Using those VR headsets, they are also called as VR box. Using those VR headsets, user is completely immersed into a virtual world, right? It would be immersed into, that user would be immersed into a virtual world, and his or her contact with this physical world would be broken completely. Suppose you are sitting in your room and you are using VR headsets. So using those VR headsets, it may be the case that you will be taken to Taj Mahal, right? As if you are wandering around, you are moving around Taj Mahal. You can even you will be able to, let's say, touch the Taj Mahal, right? Not exactly, but you will be able to feel that okay, you are actually touching Taj Mahal. But right now you are in your room, but your VR headset is immersing yourself into a virtual world. That kind of technology is called as virtual reality. Fine. In virtual reality, what happens? Users are completely immersed into a virtual world, and their contact with the physical world are broken completely. Fine. So that is what is virtual reality. Where it can be used? Applications. Application is for gaming and entertainment. For gaming and entertainment purpose, we use VR, virtual reality. Secondly, it can be used for marketing. Right? Suppose you want to carry out marketing for tourism. So the tourist would be given those VR boxes so that they'll be able to let's say given information what are the different locations to which they can go and see different places. So for marketing also it can be used. It can also be used for training. Generally pilots are trained using virtual reality, and it can also be used for treatment of phobia. If any person has any kind of phobia, that phobia can also be treated with the help of virtual reality. So that is what is virtual reality. Next is augmented reality. Next is augmented reality. So what happens in augmented reality? In augmented reality, using camera of a mobile or computer or any other gadget, using camera of a mobile, features of the physical world are enhanced. Features of the physical world are enhanced without cutting contact with the physical world, without cutting contact with the physical world, right? In case of augmented reality, the physical world features are augmented or enhanced, right? In virtual world, what happens? In virtual reality, what happens? In virtual reality, user is immersed into a virtual world. But in case of augmented reality, user remains in the physical world. But the features of physical world are enhanced. For example, suppose there is a chair in your room, and when you see it through your eyes, only you are able to see the chair, right? Now, if you see that chair through the camera of your mobile phone, it may be the case that on that chair you will be able to see a Pokemon sitting. A Pokemon, that is a cartoon sitting on that chair, you will be able to see like that. That is what is augmented reality. So what has happened in this example? In this example, when you see it through your eyes, it is only a chair. But when you see through mobile phone, what has happened? The chair or the features of chair have been augmented, and there would be a Pokemon or a cartoon sitting on that particular chair. That is what is augmented reality. There are two key differences in augmented reality and virtual reality. First, in augmented reality, there is no virtual world which is present in virtual reality. And second, in augmented reality, contact with the physical world are not broken, which happens in the virtual reality. In virtual reality, contacts with the physical world are completely broken. That does not happen in augmented reality. Fine. Applications. Again, augmented reality is used for gaming and entertainment. It is used for gaming and entertainment, and also it can be used for marketing. For example, if you visit Lenskart's app, you will be able to try those lenses on you, and that is again augmented reality, right? You can try the lenses, and these days this kind of feature is introduced in many apps. For example, even if you want to buy any watch, you can try that watch from the website of that particular brand, right? You will be able to try it on your hand. How does it look? That is possible, and that is because of augmented reality. Fine. So these are the applications of augmented reality. Next now. Next is mixed reality or MR. Mixed reality or MR. So what is mixed reality? It has features of both VR and AR. It has features of both virtual reality as well as augmented reality. And what happens in this particular case? In this particular case, users can immerse themselves into the virtual world. Right? So users, what can happen in mixed reality? Users can immerse themselves into the virtual world, and this is the feature of VR. This is the feature of VR. Without losing their contact with the physical world. And this is what is the feature of augmented reality, right? So this feature, user is immersed into virtual world, is related to virtual reality, but the maintenance of contact with the physical world is a feature of augmented reality. And that's why we can say that mixed reality has elements of both virtual reality and augmented reality. Fine, so that is what is mixed reality. Now, one more. And that is extended reality, or XR. XR is not a new technology, right? So, it is not a new technology. It is not a new technology. Then what it is? It is a term used for, it is a term used for the technology when the boundaries between VR, AR and MR gets blurred, right? There would be a time in future when we use VR, AR and MR on a very large scale. It would be the case that the boundaries between these three technologies would get blurred, and that's why a new term would be used for that particular technology, and that term is extended reality, right? Extended reality is a new term that would be used for the technology where the boundaries between VR, AR and MR would get blurred, right? So that is what is extended reality, and this extended reality would be of very use. It would be of use for us to access what is called as metaverse. What is called as metaverse? So next is metaverse. What exactly do we mean by metaverse? Metaverse is a shared, interconnected virtual world. Metaverse is a shared, interconnected virtual world that can be accessed with the help of our avatars, right? So this is the future. So there would be a virtual world, right? This is physical world. Similar to that, there would be a virtual world, and that virtual world would be a shared space. That means it is not only meant for one user. There would be a number of users. For example, in the physical world, when you go to shopping mall, is it the case that you are the only guy present there? No, it is not the case, right? There are many people in that shopping mall. Same thing would happen in the virtual world. In virtual world, that virtual world would be a shared space. It may be the case that in that virtual world there is a shopping complex, and that shopping complex you can access with the help of your avatar. You'll have to create avatar so that you will be able to access that shopping complex, right? And there in that shopping complex, you can meet your friends as well. Why? Because it is a shared space. It would be the case that there would be number of users that are coming there, and you can meet those users the way it is done in normal, or the way it happens in the physical world shopping complex. That's why it is called as a shared, interconnected virtual world that can be accessed with the help of avatars, right? And in this particular metaverse, users can own properties based on transactions in cryptocurrencies. Based on transactions in cryptocurrencies, right? So that is what is a metaverse. Fine. How we can access metaverse? We can access metaverse with the help of extended reality. Using extended reality, we will be able to access metaverse, right? So that is what is metaverse, a parallel universe, but the virtual world, virtual one. Next now. And UPSC has asked a question on metaverse in 2024's prelims examination. Next, 3D printing. Next technology that we are going to discuss is 3D printing. So what exactly is 3D printing? 3D printing is additive manufacturing. 3D printing is additive manufacturing, and this additive manufacturing is carried out on the basis of it is additive manufacturing. What is additive manufacturing? So let me discuss firstly additive manufacturing and then we'll discuss this point. So it is additive manufacturing where final products are produced by laying down layers of raw material one by one. Okay, what it is? It is an additive manufacturing where what happens, layers of raw material are added over one another to produce the final product. For example, suppose you want to manufacture this block. You want to manufacture this block using 3D printing. So how it would be manufactured? This block would be manufactured by laying layers of raw material one after the other. Layers of raw material would be laid one after the other to produce 3D printed object, right? So that is why it is called as additive manufacturing. Layers of raw material are added over one another. Fine. It is different from 3D printing, is different from traditional manufacturing. Traditional manufacturing is called as subtractive manufacturing. In traditional manufacturing, what we do, in order to produce this final product, we remove the unwanted raw material to produce the final product, and that's why traditional manufacturing is called as subtractive manufacturing. But the 3D printing is called as additive manufacturing, where layers of raw material are laid over one another to reach the final product, right? So that's what is 3D printing and how it works. Firstly, so what you need for 3D printing is 3D image of an object. First step is 3D image of an object to be produced is required, right? What is needed? 3D image of an object to be manufactured is required, firstly. Second, and how you can get this 3D image? This is possible with the help of softwares. There are softwares like AutoCAD. Using AutoCAD software, you can get 3D image of the product that you want to manufacture, right? So that is one. Second step is slicing software. You need a slicing software, right? There would be a software available, and that software is called as slicing software. What this slicing software does, it slices the 3D image into number of files, right? What it does, this slicing software, it cuts the image into number of files, right? So that would be done by slicing software. And once you have the number of files, what you do, you need 3D printer. You need 3D printer. These files would be feeded to 3D printer. Sliced files are feeded to 3D printer, which executes them one by one to produce final object, final product, right? What happens in 3D printing? In 3D printing, firstly you need 3D image of an object. That 3D image would be sliced into number of copies, number of files by the slicing software. Once you have sliced files, those sliced files would be feeded to 3D printer. This 3D printer would execute those files one by one, thereby the final product would be manufactured. So that is how 3D printing works. 3D printing is important because you will be able to develop very intricate design products using 3D printing. Those intricate design products might not be possible with the help of normal manufacturing, but they can be developed with the help of 3D printing. And with the help of 3D printing, you can develop, let's say, you can develop defense products. In space, if something is required, then that product can also be developed. For example, recently in May 2024, one of the private space agencies in India has developed a 3D printed launch vehicle. 3D printed launch vehicle was developed by that private agency, right? So such products can also be developed with the help of 3D printing, right? So that is what is 3D printing. This is a keyword, you should remember this: additive manufacturing. Next is 4D printing. Now, what is 4D printing? 4D printing is 3D printing carried out using intelligent materials. Right? 3D printing that is carried out with the help of intelligent materials is called as 4D printing, right? In these means, what are the examples of these intelligent materials? Live tissues are an example. Even resins, hydrogels can also be used for can also be used as intelligent materials. So why these materials are called as intelligent materials? These intelligent materials can change their size, shape, color based on external environment. Right? Based on external environment, these materials would be able to change their size, shape, color, and that's why these materials are called as, that's why they are called as intelligent materials. That's why they are called as intelligent materials. I hope this is clear to you. Fine. And where exactly we can use this, where exactly we have the application of 4D printing? For example, 4D printing is used in the production of stents applications. Medical sector. For the production of stents, right? Stents are used in the patients suffering from cardiovascular problems, so that their blood flow is regulated properly. For those patients, stents are used, and those stents can be manufactured with the help of 4D printing. It can also be used for the manufacturing of footwears and textile, footwear and clothing. Footwear and clothing, for example, military uniforms. Military uniforms need to adapt with the changing external environment, and that is possible with the help of 4D printing. And it can also be used in aerospace. Aerospace sector it can be used, because in aerospace conditions keep on changing, right? And that's why there is a need to have a material that would be able to adjust with the external condition, and that is possible with the help of 3D printing plus intelligent materials, and that is nothing but 4D printing, right? So that is what is 4D printing. I hope this is clear to you. Next, now we will be moving towards our discussion of very important technology called as blockchain technology, right? Let us discuss about blockchain technology now. So as you can see, in the blockchain technology, what we have blocks. We have these blocks, and in these blocks what we have information. In these blocks what we have information, and as this information is stored in an encrypted format in the blocks of blockchain, it becomes secure information, right? Blockchain technology stores the data in a secure manner, and that is one of the most important features of blockchain, right? So let us try to understand what exactly is blockchain technology. So you can just see that it is a kind of chain of blocks, right? We will discuss what exactly are they. So what exactly is blockchain? Let us try to understand. Blockchain technology is a public ledger. Public ledger that stores information in a decentralized manner. Right? It is a public ledger. Public ledger. What is ledger? Ledger means account keeping system, account keeping mechanism. For example, when you go to a traditional grocery shop, you will be able to find that person has a red color book. Often it is a red color book. So in that red color book, all the information about the products that person has purchased, sold, then all the details of accounts would be kept in that particular red color book. So that red color book is ledger, account keeping mechanism. Blockchain technology is also a kind of ledger, but this ledger is public ledger. That means person who is involved in the blockchain network, let's say there are 10 people involved in a blockchain network, all those 10 people will be having a copy of the transactions, and that's why It is called as a public ledger. What it is a public ledger. That means a copy of information about the accounts would be available with all the members of that particular blockchain network, and that's why it is called as public ledger, right? It ensures, next point, it ensures security, transparency and immutability of data. Immutability of information stored. Information stored. Right? In blockchain technology, as information is stored in a decentralized manner, the information, and also as information is stored in an encoded manner, in an encrypted manner, information is secured. Right? Secondly, the information is transparent. Why? Because all members of the blockchain network have a copy of information, and that's why it is transparent. And also it is immutable. The information stored in blockchain is immutable. That means no one would be able to change that information unilaterally. The members of blockchain won't be able to change that information on their own. If they want to change the information, they need consensus. Next point. It works on consensus mechanism. Blockchain technology works on consensus mechanism. Fine. So that is what is blockchain. In nutshell, in simple terms, what you can say about blockchain. Blockchain is a kind of database. It is a kind of database where information is stored in a decentralized manner, so that the information remains secure, transparent and immutable. Immutability is because of the consensus mechanism that is used to change the information on blockchain. That is what is blockchain technology, right? Simply put, what it is a database where information is kept secure and in a decentralized manner. That's it. Fine. Now, what are the applications for which blockchain can be used? What are the applications for which blockchain can be used? Blockchain technology has been popularized by cryptocurrencies. Like bitcoins. Blockchain technology has been popularized by cryptocurrencies. Cryptocurrencies means those digital currencies which use blockchain technology as the technology for their trade and transaction. Trade and transaction of cryptocurrencies is based on blockchain technology only. Okay? So that is one application. For cryptocurrencies like bitcoins, blockchain technology is used. Next, it can also be used for, or it is also used for, non-fungible tokens, NFTs. Non-fungible tokens or NFTs. Now, what are non-fungible tokens? Non-fungible tokens can be any digital asset. It can be any digital product, or it can be a digital copy of physical product, right? What is NFT? NFT can be any digital product. For example, it can be any video, any picture, any song, it can be anything, right? Or it can be a physical world object, but in its digitized form. For example, it can be a painting, physical painting, but we have to create, we have to take a picture of it, we have to have a digital copy of that painting, then only we can say that it can become a part of non-fungible token, right. So, coming back to our definition of non-fungible tokens, it can be, non-fungible tokens can be a digital product or a digitized copy of physical product that is one of its kind. That product is one of its kind, and if it is one of its kind, it becomes non-fungible. It cannot be traded with someone else. Why? Because it is one of its kind, and whatever is one of its kind becomes non-fungible. Suppose, consider that this is the marker and there is no other marker like this. In the world, there is no other marker like this. So, if there is no other marker like this marker, can I exchange it with someone? Can I exchange it with someone? No, it is not possible, because that person with whom I want to exchange this marker does not have this kind of marker, and hence this marker, which is one of its kind, becomes non-fungible. So, non-fungible tokens are those digital assets or digitized copies of physical products which are one of its kind. And how they become one of its kind? They become one of its kind by registering them on marketplaces called as NFT marketplaces. They are registered on NFT marketplace, and based on that NFT marketplace, they become one of its kind. And that NFT marketplace works on blockchain technology. NFT marketplace works on blockchain technology. Okay? Next now. It can also be used in elections for storing votes. It can also be used in health care data storage, right. It can also be used in healthcare data storage, and lastly, it is also used in the upcoming generation of internet called as Web 3.0. In the upcoming generation of internet called as Web 3.0, we will be using blockchain technology, because the database for Web 2.0, right now we are using Web 2.0. Next, in few years, we will be moving towards Web 3.0. The database of Web 2.0 is a centralized database, but the database in Web 3.0 will be decentralized database, and that decentralization would be possible because of blockchain technology. Fine. So, that is what is blockchain technology. Next now. Now, we will be moving towards our discussion of cyber security, but again before that you can check the RAO'S Academy for Competitive Examinations app, which is available on Play Store, and also you can check these two test series for MPPSC Prelims 2025 and APPSC Group 2 Mains 2024. Next now. Now, we will be moving towards our discussion of cyber security. Right, we will discuss about cyber security. Now, first of all, let us try to understand what exactly do we mean by cyber security and why this term is used. So, cyber security is a security that is provided against cyber attacks. Cyber security is provided against cyber attacks. Now, what exactly are cyber attacks? Attacks in which cyber attacks are such attacks in which computers are used as a tool or target. Right? In cyber security or in cyber attacks, for carrying out attacks, computers are used as a tool. Computer can be used as a tool or it can be a target. Computers can be used as a tool or computer would be the target of such attacks. Such attacks are called as cyber attacks. And when we provide security, when we want to establish security against such cyber attacks, that security would be called as cyber security. Fine. Cyber security is provided against cyber attack. Now there are number of types of cyber attacks. For example, first is system based attacks. That means a particular computer system, a particular let's say network of systems would be attacked. So what are those system based cyber attacks? First is virus. So virus is nothing but a computer program. It is a self-replicating malicious computer program, and once installed, it would steal information and also it would spread from one device to another. Right? So it can also execute instructions that cause harm to the system. It spreads without the knowledge of the user. That is what is a virus. It is one of the cyber attacks. It is self-replicating malicious computer program that replicates by inserting copies of itself into other computer programs when executed. Right? So that is one. Next, second type of cyber attack is Trojan horse. Trojan horse is also a malicious program that appears to be a normal application. This Trojan horse appears to be a normal application, but when opened or executed, some malicious code will run in the background. Right? It appears as a normal, non-malicious program, but when we open it, it would lead to execution of a malicious code on our computer. Next, that is, it is a malware that is disguised as legitimate software. It is a malware, but it would be disguised in such a way that it appears as a legitimate software. That is what is Trojan horse. It can carry out unexpected changes to computer settings, unusual activity, even when the computer should be idle. Right? Even if computer is in idle state, it would be carrying out its operations, and those operations would be harmful. Second, Trojan horse. Third, spyware. Spyware, as name suggests, is a computer program that secretly records what user does. Right? It would be spying on the user, what kind of websites are being visited, what kind of transactions are being carried out. It would even record the login credentials. That is what is a spyware. What user does, so that cyber criminals can make use of this information. For example, spyware could capture credit card details. Credit card details, login, password, all those things would be would be recorded by spyware, and that would be used by cyber criminals. Next, ransomware. Ransomware is popular these days. Ransomware is such kind of cyber attack where a computer system would be blocked, or a particular folder of that computer system would be blocked, or a particular file would be blocked until you pay some ransom to the cyber attackers. That is called as ransomware attack. So it is a malware which locks down users' access, users' files and data with the threat of erasing it unless a ransom is paid. Unless a ransom is paid, the cyber criminals will threaten that this particular system, this particular folder, this file would be deleted, erased completely. Right? So that is what is ransomware. Next, now web-based attacks. These are those attacks that will happen from the web, that means from the internet. First, phishing. Very important, phishing. Phishing is a type of attack which attempts to steal sensitive information like user login credentials and credit card numbers. Right? What phishing tries to do? Phishing tries to steal login credentials, credit card details, etc. It occurs when an attacker is masquerading as a trustworthy entity in the electronic communication. Right? It may be the case that you will feel that you are communicating with a person who knows, whom you are aware of. But in reality, it would be a cyber attacker who is using that person's identity. And in a way that would lead to, means that person, cyber criminal would let's say disguise herself as a person you know, and he or she will ask you for your login credentials, credit card details, etc. And that information would be used for malicious purpose. That kind of activity is called as phishing. Next. Next is denial of service. Denial of service or DOS. So in denial of service, what happens? It is an attack. It is an attack which meant to make a server or network resource unavailable to the user. Right? A particular server, particular network would be unavailable for the user for its use. It accomplishes this by flooding the target with traffic or sending information that triggers a crash. It would make sure that the network that you want is flooded with traffic, or it is crashed completely, and that would lead to DOS, denial of service. This renders the system unusable. Next, man in the middle attack. Man in the middle attack is that kind of attack in which between you and the intended person there would be hacker, and this hacker will try to understand all the information that is being communicated between you and the intended person. That is what is man in the middle attack. A type of cyber threat where cyber criminals intercepts communication between two individuals, right? So that is what is man in the middle attack. Next is brute. So it is brute attack, brute, not Bruce. Brute attack. So in brute attack, what happens? The cyber criminals use trial and error method in order to guess your password. In order to guess your password, cyber criminals use trial and error method. So brute force attack uses trial and error to guess login information, right? So that is what is brute attack. Next is cybersecurity technology. So these are the cyber attacks, and against these cyber attacks there is a need of security, and some technological solutions are available to build cyber security. So let us discuss those technological initiatives or technologies available for building cyber security. First is use of firewall, right? Firewall acts as a kind of wall between you, your internal private network, and the internet, so that through this firewall only intended traffic would be able to flow. Any unwanted traffic would be blocked by this firewall. That enhances security of your internal private network, and this kind of firewall is generally used in organizations. In organizations, to protect their internal networks, they use firewalls, right? And firewall can be a software, can be a hardware, or a combination of both. That is first, firewall. Next, second is virtual private network, VPN, very important. VPN. So what VPN does? VPN, it creates a tunnel for flow of data, right? So what firstly VPN does? VPN creates a kind of tunnel for the flow of data between you and the internet. Between you and the internet, there would be creation of a kind of tunnel, and all data that you are accessing will flow from that particular tunnel only. And secondly, VPN encrypts data flowing through tunnel, flowing through the tunnel. The data that is flowing through the tunnel. So when you access internet, it is not only that you will be accessing internet through this tunnel. Even whatever data is flowing between you and internet, that would also be encrypted. So two layers of security are there. First, all the traffic that you are accessing flows through a tunnel, and secondly, that data through tunnel is encrypted. And as a result of that, no one, hacker, corporates or government, would be able to understand what kind of traffic, what kind of information you are accessing from the internet. That is what is virtual private networks, right? Now, in virtual private networks, the user's IP address, internet protocol address, every computer has its own IP address. User's IP address is hidden in VPN, and that's why user's geographical location is also not known, and hence user can access any part, any website. Even if a particular website is banned in a particular country, that user can access that website as a person from some other country. That is what is VPN. VPN can help us protect IP address, protect geographical location, and can also allow users to access such websites which have been banned in a particular geographical location, right? So that is what is virtual private network. Next is IDS, intrusion detection and prevention system, IDS or IPS. So what it is, as you can see, these are those systems that continuously monitor your network for suspicious activity and can either alert you or take automated action to block potential attacks. So what is done in IDS? They continuously monitor what kind of traffic is flowing between you and the internet, and based on that, it can alert you in case some malicious activity or malicious content is flowing through the internet towards you. You will be alerted, or IDS will take action on its own. So it is an additional protective layer apart from firewall. So this is firewall and this is IDS. Fine. So that is how IDS will also protect your system from getting attacked from the cyber criminals. Fine. So that is what is IDS, and through these kind of technologies we are able to protect our data. One more is cryptography. Right? And as we have already referred to this, but what happens in cryptography? A plain text is converted into an encrypted text, and this encrypted text, it flows on the network. What flows on the network? Not the plain text. Encrypted text flows on the network. This encrypted text, when it reaches at the receiver's end, decryption would be carried out to convert that encrypted text again into plain text, right? So what happens in cryptography? Cryptography is a technology that is used to protect data over the network, so that only the intended person would be able to access that data. It carries out conversion of a plain text into an encrypted text by encoding it, and at the user's end, at the receiver's end, it would be again converted back into plain text by the process of decoding. So what happens here? Here encoding happens, and what happens here is decoding. and this encoding and decoding would be carried out based on key. Fine. So that is what is cryptography. Cryptography has two important types. First is symmetric cryptography, symmetric key cryptography. In symmetric key cryptography, single key would be used to encrypt and decrypt. One single key would be used to encrypt and decrypt messages. And second type of cryptography is asymmetric key cryptography. In asymmetric key cryptography, we use two different keys, public key and private key. Public key would be available with the sender as well as receiver, right? And the sender would encode the message with the help of public key of the receiver, and receiver would be having a private key of himself or herself. That private key would be used by the receiver to decode the message, and that's why it is called as asymmetric key cryptography, where two different keys are used to encrypt and decrypt messages. Encryption would be by public key of the receiver, and decryption would be by private key of the receiver, right? So that is what is the two types of cryptography. I hope it is clear to you. Fine. So that is about our discussion of information and communication technology. You can again check the app of RAO'S Academy for competitive examination that is available on Play Store, and you can check these two test series. First is related to UPSC Prelims examination 2025, and second is UPSC Group 2 Mains examination 2024. So these are some of the other initiatives of RAO'S Academy for competitive examination. So, and these are some of the social media channels. So that is about our discussion for today. Thank you.